Hello, calculus fans. Let's talk about the magnitude, or the length of a vector. It's the length of any of its representations, and we're going to denote it with this symbol. It looks like an absolute value, but it's got like double bars, so that's what we mean by the length of a vector. Now, some books will use a single bar for absolute value. While I wouldn't call that wrong, I think it's helpful to have the double bars just to remind us that we're dealing with vectors. Now we can use the distance formula to get the following formulas for the length of a vector. So the length of the two-dimensional vector, v, which is a1, a2, is square root of a1 squared plus a2 squared. And in a similar way, we can say that the length of the three-dimensional vector v, who has components a1, a2, a3, is square root of a1 squared plus a2 squared plus a3 squared. All right, how do we add vectors, a1, a2, and b1, b2? Well, it works exactly the way you would think. You just have to add component-wise. And subtraction works in a similar way. And if you want to multiply a vector, a1, a2, by a scalar c, all you have to do is multiply each component by c. So c times the vector a will have component ca1, ca2. Later on, we'll talk about more complicated multiplication involving vectors. Right now, we'll say we can't take a vector and multiply by another vector. We don't have an operation for that just yet. Okay, that's all for now.